I'm coming up first. Tom is going to come up in a little bit, and we're going to talk about state channels and give some updates on what statechannels.org is and the latest kind of collaborations that we've been doing, and then talk about our roadmap kind of going forward. So, like I just mentioned, what's going on with state channels, where are we going, what to get excited about. So, statechannels.org. You may have seen this website at some point. It was on Twitter, some talk about it. What we're mostly doing here is we're trying to standardize the way that state channels work in this industry. Myself and Tom and a bunch of others, who I'll show in a second, have all been working on this for like a couple of years now, and there's been a lot of progress across the tech stack, and it's come to be the point where we can begin standardizing a lot of the lower level primitives and working our way up towards something that we get mass adoption by apps trying to get benefit from this technology in the coming year. So about, I don't know, 4 or 5 months ago, we all went to New York together for an event called ETH New York and during New York Blockchain Week. And you can see here, we have people from the Ethereum Foundation, from Prune, from Stellar, from Magmo, Connect, and a bunch of companies. All together, we had a bit of like a state channel summit. We literally got into a room and we said, okay, look, what are we doing? Why aren't we collaborating more? Why are we kind of all rehashing the same work together? And we had a lot of like really great results. One thing that is important to note is that standardization sometimes can be kind of critiqued, whether you're looking at it from a VC perspective, where you might want to see one killer app dominate the industry first until you see some standards get adopted or get proposed. But one thing that we've noticed that's been critical to Ethereum's success is defining standards and defining interfaces early on has led to some of the biggest actual booms in the entire industry. Most notably ERC20. Right after that was begun to get standardized when we saw this ridiculous boom, which for the most part financed like a lot of our actual operations here in the industry. We've seen ERC 721 lead to like standard marketplaces for collectibles. We've seen 712 lead to standard wallet signing interfaces, and there's many, many more examples of once we get together, figure out how to do this thing right, the rest of the community, which is largely builders, actually begin building on top. So this is extremely critical. So these are some of the companies that are involved. We all have a really cool history. If I had more time, I'd tell you the whole story of how we've all been working together over the last little while. But we have L4, Perun, Prototypal, Connect, Seller, Magmo, Funfair, Pisa, all of these companies, and some even on other blockchains have been collaborating another time. It's been working on this problem together for the past couple of years. And it's only been recently that we've been able to all kind of come together and standardize at the lower levels. So that's quite good. And I want to just show the case for standardization. What most people don't realize about state channels is that it's not just you write this thing once and all of a sudden magically all applications go wicked fast. It's actually quite a huge tech stack that is under the hood of the word state channels, and I'll kind of show some of them. One is the most obvious one, is how do you actually progress state between two parties? Precisely, what are those objects? Precisely, what are you signing? The other one is like, how do you fund these channels? How do they actually get funded in such a way that anything you do is meaningful on the chain? That itself has yielded many papers of different protocols, many, many different standards, different across chains, networks themselves are built on top of this. The actual implementation of those engines, which themselves are large software libraries that we've seen, again, through multiple different companies implementing these things. Many archive repositories on GitHub trying to get this stuff working. The wire protocol itself, how do you communicate to other nodes? If you're familiar with Lightning and Interledger and Stellar and all these other network attempted channel constructions, these things are dramatically different across all of them. And that's what's led to years and years of lack of interoperability for the most part. And anyone here that's worked on things like Interledger, for example, know that once you start getting multiple protocols across different chains together, it's disastrous because there's no good standards. Integrations at the wallet level is as well like a massive problem. Once you actually have a good protocol that works, when you go to a wallet, it can take months and months and up to years to actually get that thing integrated well into wallets. And again, we've seen that with Lightning, where it's been taking quite a long time to actually get even Lightning-enabled wallets. And then finally, the UI itself. When we talk about end users, what does it mean to have a channel? Is it a card? Is it some other object in your channel? Is it the wallet itself? We've had so many discussions about this. And the benefits for each of these things should be extremely obvious. At each level, like for example, at the wallet UI level, when we have a consistent UI, we have one set of UI components that every wallet can standardize around and that users can have a familiar experience with. When it comes to integrating itself, we can have one API that a wallet just needs to import the API for and have a standard interface to how they open and close channels. At the wire protocol level, I kind of gave the example, communicating nodes between different blockchains is incredibly important. The implementation of protocol engines, we get this thing done right, we can reuse the code in multiple different contexts. When it comes to funding, we can also have reusable collateral, pooled collateral kind of hubs, so that if you ever wanted to, reuse a hub in the Lightning Network, in the state channels network on Ethereum, or in any of the existing state channel networks that we have on Ethereum, you would definitely want to have pooled collateral. And then obviously at the lowest possible level, if we're going to have shared contract code, if we're going to do any kind of formal verification, if we're going to do anything at all about assuring this thing actually is secure like we say it is, then we need to have at least one standardized protocol. So it should be obvious that these are ridiculously good benefits that are worth pursuing. So that's roughly the case for state channels.org and the case for standardization. What I want to introduce now is just some updates on what we've been building in a project called State Channels, which I'll get into is the collaboration between a couple other projects in the space already. So one is we've already taken the whole stack that I just described in a single implementation, and we've got it on production today. So it's been a tremendous amount of effort between our teams, Connext specifically, that have been building on top of it to get a full generalized state channels network on production today. And this is like actually a ridiculously good accomplishment. I'm talking mostly in this talk about standardization, but the fact that we've been able to have all the stuff working at the point that now we have an example with which we can begin to standardize is an enormous success. So like kudos to Connext on getting this working. And the great part is we now have a feedback loop with wallets, with infrastructure projects, with applications that are actively using this that can give us feedback on what things they would like whenever we're discussing which standards to adopt. So that's been a great success. A second thing I want to mention is what I kind of said. We're taking immediately the step of merging a project called Counterfactual, which is initially the collaboration between two other of those companies, Prototypal and L4, and Magmo, and producing a single project, which is what I just described, State Channels. And this is a phenomenal example of how once we begin to agree on standards, we can dramatically amplify our efforts. And you can see this on our GitHub, where we have now several people, extremely good engineers from multiple different backgrounds, multiple different companies, collaborating daily on building this infrastructure, which obviously is going to lead to a lot more output, a lot quicker, and a lot less redundancy, which for me and a lot of people in this room that have been working on state channels or other layer 2 constructions, the ability to say that we're all working together directly is an incredible success. So that's one good result from the State Channels.org initiative. So I kind of just mentioned a lot of that stuff. In practice, if you want to follow that specific project, we're continuing to work on it. It's called State Channels. We're going to have a smooth upgrade path for anyone that's already working on it. You can see the code today if you go to @StateChannels on GitHub. You can follow us on Twitter, and we're actively doing updates on that there. Yeah, like you mentioned, this is how you can keep in touch with that project. So yeah, that's mostly the case I wanted to make. We've taken strides through all of the recent efforts this year of standardization, immediately gotten something in production that works based on our initial and agreed upon standards, and we're now merging projects in that set of projects to get a single implementation that's going to be production ready for everybody else to take part in over the next little while. So yeah, that's State Channels. And now I'm going to pass it on to Tom, who's going to talk a bit more about not just what we've done so far, but what we're going to be doing next. Cool.
Yeah, thanks, Liam. So I'm Tom Close. I'm the founder of Magmo, and as Liam mentioned, we are one of the projects that have come together into the statechannels.org project. And I just wanted to take this opportunity to thank Liam for his role in that, and really getting the teams to work together and creating this project that's going to drive forward state channels on Ethereum and ultimately get state channels into the hands of developers. So what I'm going to be talking about here is what we've been working on in the last couple of months and what our roadmap looks like for the months coming up. So what are we actually working on in this new statechannels.org project? So this is the image you've already seen from Liam, explaining the different levels of the stack. And I'm just going to pick on a few projects that we're working on at the moment and explain and they're all from different parts of the stack, and I'm going to explain what work we're doing on each of those projects. The first project is a project that we're just calling Protocols and Contracts, and that's to do with the underlying protocols, the challenge and response mechanism, and the contracts that support that. I'm also going to be talking a little bit about our work on the client and the hub. So this is the stuff that you need if you're actually going to run a state channel. So this is going to be running on your browser, it's going to be running on a server somewhere, it's going to be running the wire protocol, it's going to be storing your states and all sorts of things like that. And then finally, I'm going to talk about a few things from right at the top of the stack. And in particular, I'm going to focus on some of the ideas we've been discussing around browser and wallet user experience. Use of state channels introduces all these additional challenges in terms of how you explain what you're doing to a user and how you interact with the user. So to start off with, I'm going to start talking about these protocols and contracts project. So this is where the majority of our work has been so far. So protocols, the underlying protocol and the contracts form the foundation upon which the rest of the stack sits, and changes in this layer have to ripple up all the way through the stack. So at the beginning of this collaboration, we've been focused on trying to get consensus at the base layer, having a firm foundation that we can then build on top of. So we came to this project with we each had our slightly different protocols, and over the past couple of months, we've been working to merge them together and work towards a point where we can actually freeze these contracts in this protocol. So there have been a couple of different areas that we've been working on here. The first one that I'm going to talk about is protocol hardening. So this goes to, I guess, the very essence of what you're getting from a state channel. And the guarantee that you want to give people is that a participant in a state channel should be able to progress that channel or terminate it and withdraw their funds within a fixed time, regardless of the behavior of other participants. So even if you're the only honest participant in a channel, you should still have safety. You should still be able to withdraw your funds if you need to, and not have them indefinitely locked in the channel. So we've been looking into this. When we came into this, we were pretty sure that our protocol was already pretty good and didn't have many holes. We'd been thinking about it for a long time. And then we started using this new tool. So we've been using this tool called TLA Plus, which was I guess it's a protocol specification language and protocol verifier and checker that was invented by Leslie Lamport. So it's for checking the behavior of distributed systems. And we built a model of our protocol in this specification, ran it through the checker, and it just threw up a ton of problems that we hadn't thought about. So this was really interesting, and in a minute I'm going to point you to somewhere where you can find out more about it. To give you an idea of the sort of problems that it threw up, it was things like if you are able to front-run transactions. So it's pretty easy to design a state channel framework so that if I can get a transaction into the chain, then I can definitely progress the state channel. What we started thinking about is what happens if you can get a transaction into the chain, but if your opponent can get another transaction in before yours, what happens then? And we found out in certain circumstances, your attacker could lock the channel forever, which is pretty bad. So this was really interesting. I think we're now in a place where we've closed up a lot of those holes. If you want to find out more about this, you should go to this research forum, which we've open sourced today. So if you go to research.statechannels.org, you can see about a lot of the conversations that are going on, some of the things that have been highlighted by the TLA Plus stuff, and other conversations about the protocol level of this specification. And later we'll also have, this is basically going to be our place where we discuss all the changes to this protocol. Right, the next thing that we've been working on is gas-optimized contracts. So as you're probably aware, the whole point of state channels is to help chain scaling and throughput. And your ability as a scaling solution is very much limited if it costs a lot to open and close a state channel. So for us coming into this project, this was a very important thing. We want it to be really cheap to open and close a state channel in the happy case, and also as cheap as possible to launch a challenge and respond to a challenge if there's bad behavior. So we have these two metrics. The first one, which I've just described, is the happy path, and that's how much it costs to deposit into the state channel, to close the state channel collaboratively, and then withdraw your funds. And when we started out, this was pretty expensive. So this was 600 gas, which is, I guess, like 30 transactions, maybe slightly fewer than that, but like that's pretty significant. Like you need to be doing quite a lot of activity in your state channel to make it worth it if it's this expensive. And we've now managed to get that down to 165 if you're using ETH, and 185 with ERC20. So these are changes that have happened in the last couple of months. Most of these changes are due to like basically reducing the amount of stuff you store on chain. And we think we can do even better than that. This is before we've started like batching transactions and stuff, so we think we can bring this down even further. And the second part of that is the challenge path. So how much does it cost to launch a challenge if your opponent blocks? And then how much does it cost to respond to that challenge? And this was originally a whopping 1,100 gas. Can't even read numbers anymore. And we've now managed to get that down to 200K gas. So we're beginning to get into the range where these things make sense, and it makes sense to use this as a scaling solution. Finally. And the final part of this that we've been working on is the protocol and contract documentation. So if you want to find out more about these protocols today, you have to go and read a couple of different research papers, and most of those papers are out of date because of these changes that we've made in the last couple of months. So what we've been trying to produce is an authoritative and always up-to-date specification of the protocol and contracts. So this living documentation that's always guaranteed to have the most accurate, up-to-date information. And we've made some progress on that. This is still work in progress. We hope to be able to release this in the next couple of months. But this will exist in the future, and this is an important part of what we're working on in order to help the community like understand and use this framework. So our goal here, this is going to be the focus mostly for our next 3 months. So we want by the end of 2019 to be able to freeze and release the V1 protocol. And that's going to include a fully robust protocol, the optimized and verified smart contracts, and full documentation. Okay, so I'm now going to talk a little bit about the client and the hub. So this is work that we're doing in parallel, but so this is like teeing it up for the next thing that we're going to work on when we've managed to freeze the protocol. So the goal here is to provide a reference client and hub that implement the protocol. And this will be something that wallet users can take, wallet creators can take and put into their wallets. It's going to have libraries that if you want to build everything from scratch, you can. And it's basically going to have the design patterns of actually how to interact with this protocol. And there are lots of things this needs to do. So we're merging these two code bases, one from Counterfactual and one from Magmo. And both of these code bases did a subset of these things. And we're trying to merge them together to get one that does everything that it needs to. And so that includes robustly storing your states, because your states are like money in a state channel. If you lose them, you can lose money. Validate transitions, detect and respond to on-chain challenges, launch your own challenges if you need to, and support virtual channels through the hub. So this is another part of the work that we're working on, and we'll also be working pretty hard to try and merge those code bases together over the next 3 months. And finally, I want to talk very briefly about some browser wallet UX design things we're thinking about. And these are things that I think the whole community will have to get involved in. But we're trying to build an example application and have been thinking a lot about what the actual user experience with a state channel could look like. So questions that we're thinking about here is, how should a user interact with a state channel? How do you explain to a user that they're locking some funds and then they're going to be able to do on-chain things, but their funds are kind of locked and they have to do something to get out? Another question is, can we avoid approving every single signature? So anyone who's used the dApp today will be used to getting a MetaMask pop-up. Now, the whole point of state channels is to allow multiple transactions a second, and you don't want to be doing multiple MetaMask pop-ups a second. So can we avoid that? Can we allow the wallet, can we allow our client to sign some things for you? And in that case, how much does the user have to trust the app? You know, if the client is just going to sign things that the app sends to it, how can we keep the user safe? Which is this next question: to what extent can your channel wallet protect you? And then finally, what policies should a channel wallet be able to enforce? And very quickly, we're beginning to think that for state channels, the thing that makes sense is to have a policy-based permission system. So you approve a budget for an app rather than you're approving each channel or each interaction. So you could imagine maybe something will look like this in the future. Your channel wallet pops up, it asks you to approve a budget. It will ask you to approve a spend budget of 2 ETH for a given site. You approve that, and then your channel wallet takes care of everything else. It opens, it closes virtual channels. It opens channels when it needs to. It closes them. The only constraint is it doesn't go above that 2 ETH limit. So yeah, if these things are interesting to you, or if you've got a use case and want to have input into how we're thinking about this stuff, please come and talk to us, or go to the State Channels Research Forum. These are the sort of conversations we want to have with everybody in the community. So yeah, that's it from me and from Liam, who has now disappeared. But stay tuned. So this is ongoing work. Follow State Channels on Twitter, and thanks for listening.